Welcome to SanfordFlipMath. This is PreCalculus, and we are working through the Demana, Waits, Foley, Kennedy PreCalculus book. And we are currently in the midst of working with trig identities. And we have just spent a couple videos talking about how to simplify trig expressions using known trig identities. And they look something, oh, there they are, something like this. And today the focus is going to be on, I'm going to use the P word, and this is a word from geometry, but it doesn't look like what we did in geometry, so I don't want you to freak out. We're going to do what's referred to as proving or verifying trig identities. In other words, we're going to use these identities that we already know to try and show that another identity or a new potential identity is true. Okay, so just to have a quick little idea of what we're talking about, tangent x over secant x supposedly, or could be, equal to sine x. And so what we're going to do is try and show that that's true. Okay, so before we do that, just a couple little tips here. Okay, first of all, so to prove an identity or to verify an identity, the goal is to show that both sides are the same. Both sides of that equal sign are the same. You have three options. You can work only on the left side and trying to get look like the right side. You can choose to only work on the right side and try and get it to look like the left side, or it is okay to work on each side, both sides, but only one at a time. And I'll clarify what that means when we start seeing some more interesting examples. But here's the issue. We're trying to show that those two things are equal, trying to show that they're the same. So I cannot do things like in normal algebra when I'm solving an equation, you know how you can add on both sides and cancel stuff out, or multiply on both sides, or cross multiply. You can't do any of that in this. Okay, so this is not like in Algebra 1. This is work on one side and then you stop. Work on the other side and you stop. And you'll see what I mean in a minute. Okay, so let's take a look at that example that we just took a peek at. And again, the goal is to try and show that tangent divided by secant is the same thing as just sine. Okay? Well, so honestly, what we're going to do is kind of the same thing we were doing in 5.1, where I'm going to try and simplify this left side, and hopefully the answer I get is sine. So in some ways, this is easier than what we did in 5.1 because I already know what the answer is. I know what the goal is. The goal is to make them look the same. Okay, so what I want to do first is I'm going to draw a little line down the equal sign. And the idea, this is just to help me remember that I don't want to work across the equal sign. I cannot multiply both sides by secant because I want to, you know, I'm not a fan of fractions, so I'm going to multiply both sides by secant. No, you can't do that. That is totally against the rules because that is assuming that this was an equal sign. This actual equal sign is valid. And what I'm trying to do is prove that it's valid. Okay, so just a quick word of warning there. Don't work across the equal sign. Okay, so I'm just going to work on this kind of like I never, you know, as if I never saw this here. I'm going to pretend like it was section 5.1, and my goal is to make it equal to sine. Okay? All right, so here we go. So instead of writing tangent, now I know that I want this to look like sine, so I'm going to do the whole sines and cosines thing. So here are those strategies that I've been working with. Okay? So I'm going to change this to sines and cosines. So sine over cosine, sine of x over cosine x, over 1 over cosine. Well, that's kind of disgusting looking. Now, there are two ways to approach this. I could multiply by the reciprocal of the denominator, or I could just multiply the top and bottom by that one denominator. So this is going to divide those out, and I'm left with sine of x, and that's over 1. So now remember what the goal was? The goal was to make the left side look like the right side, or make the right side look like the left side. When these match, we are done. Okay? So that's it. Now obviously that was like the easiest problem in the West, but let's do another. Okay? Now again, I want to make the left side look like the right side, or make the right side look like the left side. And again, I'm going to draw a line down here so I remember not to do things like multiply both sides by that denominator and clear it. I can't do that. That would assume they're equal. Now, I have a rule that talks about tangent squared and secant squared equaling 1, that's one of those Pythagorean identities, but this doesn't say squared, so I can't just stick some squared in there. I can't use that. Okay, so I guess I'm just going to do sines and cosines. So tangent is sine over cosine, 1 over cosine. Now, cool thing about this is it actually has a common denominator. So I can actually combine these. So sine plus 1 over cosine. Okay, so when you add fractions, you just keep the denominator if it matches, and then add the numerators. Now, sine plus 1 over cosine, cosine over 1 minus sine, those are not the same thing. So what I am going to do is I'm going to play with the conjugate. Now, why would I use the conjugate? Well, if you notice, I have a 1 minus sine here. Wouldn't it be really nice if this said 1 minus sine here? Well, I can't just do that on the bottom. I have to do that on the top also. So what I'm going to do is multiply the top and bottom by 1 minus sine. Okay. So in the top, I have 1 times sine. I have outer. I have inner. And last, all over. Now, it's very tempting to distribute out this cosine times 1 minus sine, but I know that there's a good chance that there's going to be a cosine to cancel out. Now, how do I know that? Well, I don't see a cosine over here. So I'm going to just rewrite it like it is. I don't have to distribute it. It's still equal to that, even though I don't distribute. Okay? Now, that looks like a lot of stuff, but it's really not as much as you see. I see a positive sign, and a negative sign. So what's left then is 1 minus sine squared over, and again on the bottom, still 1 minus sine times cosine. I know this is feeling like a long problem, but we're only a couple steps away. We're almost done. Remember the goal, cosine over 1 minus sine. I see the 1 minus sine here, okay, and the top, that top looks like one of my Pythagorean identities. Notice the squared. So I see 1 minus sine squared here. Just to confirm, 1 minus sine squared. Well, if I subtract sine squared from both sides of this, wouldn't that be 1 minus sine squared? And it would be equal to cosine squared. Well, if that's true, let's go this way. There we go. So 1 minus sine squared is cosine squared. That's over 1 minus sine times cosine. Now, I'm almost there. Notice I have, this is a factor of cosine on the bottom. I have 2 factors of cosine on the top. So this becomes cosine over 1 minus sine x. Now, what was the goal again? Cosine over 1 minus sine, cosine over 1. Oh, I'm there. I'm so excited. All right, so those match. That's what I need. Okay? All right, so again, the goal is to get them to match. I don't need it to be simplified per se. I need it to match. Okay. Okay, so let's do another example. Okay. All right, so again, keep in mind the goal. Now, be careful. Sine squared minus cosine squared, that is not the same thing as sine squared plus cosine squared. Sine squared plus cosine, stop that. Sine squared plus cosine squared is 1. Okay, sine squared minus cosine squared is not. Okay, so what can I do to make these two match? Okay, so again, I cannot do anything across the equal sign. I cannot add cosine squared. I cannot subtract sine squared. I can't do anything like that. Okay, so I need to find a way to make these two match. Now, I would like to remind you, we do have that, you know, we did just kind of, where to go? Squared. That's it. Okay, so I got a lot of squared stuff in here, so it's probably something about a Pythagorean theorem. Okay, now again, we do have sine squared plus cosine squared equals 1. If you notice here, there's a 1 minus. Well, what I'm going to do is I'm going to subtract cosine squared because I want to make that other identity into something. Okay, so let me do this and put that down. Stop. I'm just trying to unhighlight that. Sorry about that. All right, so what I want to do is a little substitution. Okay, so if I do this, sine squared equals 1 minus cosine squared. And we've seen this before. Okay, and then what we're going to do is in place of sine squared, we're going to replace that with what it's equal to, 1 minus cosine squared. And then the other minus cosine squared was already there. Those kind of look like terms, don't they? So negative 1 cosine squared, and then negative 1 cosine squared makes a negative 2 cosine squared. I have that 1. And what else do I need to do? I'm done. Those match. Okay? Until they match, I'm not done. Now, please note that you need to do actual mathematics. I need to see the substitutions happen item for item. You cannot just like throw something in there, jib, 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 and look, I got them to match. You know, that doesn't work. Okay? All right. This is a little scary looking, and let me just say that some of what makes this scary looking is this Greek letter, beta. It functions like a B, and I don't know what it is about math people and trying to use letters from some other language. You know, in Algebra 1, we decide we're going to stick an X in there just to keep track of some numbers. And then I guess, you know, by the time we get to, you know, higher level math, we think, oh, well, our letters aren't good enough anymore. We got to keep it even more interesting. So here it is, a Greek letter, like theta, and we got beta in here now. And there are some others that'll pop up. Okay? All right, so what we're going to do is try and make the left side look like the right side, or we can make the right side look like the left side. Now, for the most part, I've been working with just the left side. You don't have to work with the left side. You can work with the right side. So I'm going to work with the right side, just to mix it up. Okay? All right, so one of the things that we've been doing a lot of, or, well, not a lot of, in this section, we're seeing more of it, is the conjugate. So I'm going to multiply the top and bottom of this side by the conjugate. Instead of 1 minus sign, I'm going to do 1 plus sign. Now, my reasoning is twofold. The biggest reason is, like on the last one we saw, like this, there's this 1 plus sign beta in here, and that gets me a 1 plus sign beta in the bottom. Okay, so that's cool. So let's do some multiplying. Now, like on the last one, like this, and actually this is very similar to that other one, I'm not going to actually multiply out the bottom. And again, the reason is that I kind of expect this guy to cancel out at some point. I don't know if it really will. We'll see. Oh, I didn't want to get rid of all of that, did I? Sorry. Okay. On the top, I am going to distribute this out because I'm hoping it's going to be equal to something else. So I'm going to FOIL 1 times 1. Outer is going to be a positive sign. Inner will be a negative sign. They add up to 0. You might want to write that out so you see it. I just think you need to get to the point where you don't have to. Okay, and then negative sign times positive sign is minus sine squared. Okay, now we just saw on the last problem something very similar to this. Well, 1 minus sine squared is equal to cosine squared. So here it is, cosine squared beta over cosine beta. Yes, write the beta. It doesn't matter what letter it is. It's just going to follow the same function like an x or anything else. Okay? Okay, notice there's a common factor now. There are 2 of those up here and 1 of those down here. It cancels out or divides out. 1 plus sine beta. Okay, what's left? What else do I have to do? Well, I just need to say, hey, look, they match. Woohoo! Okay, so I'm good. All right, sounds exciting to me. All right, one more. Oh, dude, this looks scary. Actually, this one isn't bad. Okay, I want you to take a minute and look at it and see if you can see anything. And so hit pause right now and see if you have any ideas. Okay, go ahead. Okay, now, if you didn't have any ideas, I'm going to give you a thought here. Notice that this is tangent. And tangent, remember, is sine over cosine. Sorry, of A. Well, if I had a cosine right here, cosine A, then I'd have tangent. But I can't just divide like one term by cosine A. Let's divide every term by cosine A. So if I do that, just looking at the stuff that's going on here, this would be tangent A. That's this. This would be 1. That part of it, there is a 1. This would be tangent A. And this, that part would be 1. Okay. Now there's supposed to be a tangent here though. So this is sine, for tangent I need sine over cosine. So let me do cosine. Excuse me, and that's just to be. Now again, if I'm going to do that, I have to do every single term. Okay, so I'm trying to get you to look at pieces to get hints. Okay. All right, so what happens when we do that? Well, here's my tangent B. That matches. That's cool. Now, this one I had the tangent of A, and I really didn't want this there at all. And look, they cancel out. And then on the bottom, well, I wanted this thing to be 1. Well, this divided out to be 1, and now this divides out to be 1, so 1 times 1 is 1. Okay, so up on the top, that was tangent A. Okay, on the other part of the top, this part is 1. This is tangent B. Well, 1 times tangent B is, you guessed it, tangent B. And then here, this is tangent A. And this is tangent B. Well, what was the goal? Yeah, I did it. I got them to match. Okay, so look to the other side for a hint. Okay, that can give you a hint. Okay, now, okay, let me see what's going on. Okay, let's just do one more. Okay, this will be our last example. And this one, I wanted one more example so that you could see us working kind of on both sides. Okay, and be careful with this. Now, I'm still going to draw my line down the middle. And what I'm going to do is on the right side, I'm going to write this as 2 times 1 over sine t, which you might write as 2 over sine t. You don't need to. Okay, so I worked on the right side a little bit, and now I'm going to stop. I'm not going to multiply both sides by sine and cancel out anything. I'm just going to stop. Now, please note that whenever I work on a side, I go down. So work your way down, and this could end up being a long column on a sheet of paper, and that's just too bad. But sometimes what happens is people try and work across, or they work across over here, and then they come over here and work. Don't do that. Work down. It's too hard to keep track of what's going on if you do that. Okay, so please just work yourself straight down. Okay. All right, so I'm going to leave this alone on the right side now because I don't really know of anything else to do to this. I've made it as clean as I can in terms of sines and cosines. Okay, looking at the left side, I don't see, first of all, everything's already sines and cosines. I don't see any squared stuff. I guess what I'm going to do is get a common denominator. So I need a factor of 1 plus cosine t in both denominators. Well, I can't just multiply one thing. I have to multiply the top and bottom. Okay, that's kind of squished, I'm sorry. Okay, and I also need a factor of sine in both denominators. So I'm going to multiply the top and bottom of this by sine. Okay, now whether you multiply out the bottom or not doesn't really matter to me. I'm going to leave it for right now. I kind of hate multiplying stuff out and then later think, oh dang, I should have left it alone, and then I have to factor. Okay, so that's the bottom. It's the same denominator on both fractions, so I can have one big fraction with that one denominator. The tops I will add. Okay, so sine times sine is sine squared. Okay, that's going to be something squared. Yes, t works just like x. Just bring it along. Plus, I need to distribute this out. I need to FOIL it. Okay, so 1 times 1 is 1. Outer is going to be cosine t. Inner is going to be cosine t. And then last is going to be cosine squared t. Okay. All right, so a couple things that I notice here. First of all, I have this 1. I have a cosine t and a cosine t. So you guessed it, that's 2 cosine t. Okay, that's not cost, that's cosine t. And then the other thing I have is, it's that doggone telephone again. I have sine squared plus cosine squared, which is 1. Okay, now don't forget your denominator, okay? So the denominator was sine of t. Okay? All right, one more little simplifying thing, and then we got to get serious about being clever. Almost there. Mr. Sanford, is this problem ever going to end? Well, I can't do a 50-minute video. I know some people think I do already, but I can't. All right. Well, notice that on the right side, I'm supposed to have a 2 in the numerator, which means I really need just one of these 2's. Well, there's more than one way to make 1 2. I'm going to factor it out. On the bottom, so just stare at it for a second. The idea is, if I distributed this back out, I would end up with that numerator again. Okay. Well, this is the same factor. So this is 2 over sine of t. Well, what was my goal? Sweet. Now, some of you, sorry, I just coughed in your ear. Some of you, I know, would have left the right side of this equation alone completely. So if that's true, you know, and there's just more than one way to leave this, okay, I'm done. I don't have to keep going. I just want you to see that I could have thought of this then as 1 over sine t, 2 times 1 over sine t, also known as 2 cosecant of t. So it would have been perfectly valid to leave this like this, and those match instead, and not touch the right side at all. Okay, so there are options here. Okay, well, I'm going to leave it at that. That's lots of examples you've seen, lots of the techniques in Flow. Be patient with yourself. Don't give up. Keep learning the formulas. Keep practicing, because the more examples you see, the better this is going to get. Okay, so we'll be working on these 2 sections, 5.1 and 5.2, for a little bit, and then we'll have to add on the rest of the identities. We still haven't touched the sum and difference identities, which are these guys on the bottom. And again, that's in section 5.3. And these, with a few more, are in section 5.4. Okay? All right. Thanks much. SanfordFlipMath. Bye.